I think we're online. Microphone is unmuted. I think you can see more or less everything that is of interest. I might pull the camera a little bit over, like so, so that you can see more of the board. And I'm gonna wait a couple of minutes because I think there's not much traffic in the stream right now. Yeah, but I can see myself in my iPad monitor, so that's good. And yeah, so hi. We had another of this great live streams 2 weeks ago or something, and I took apart this wonderful great Atari 7800, which was the third console that Atari brought to market after the seminal 2600, the first really proper games console from 1977, I think, with cartridges like these here, with different games on it, color and joystick inputs, pedal inputs, that is for pedal games basically, like Pong, etc. And the 5200 was a bit of a flop, I would say. It came out right around the 1983 video game crash, so I think those are rather rare. The 7800 had a better and longer life, but I think it basically didn't sell as well as the 2600 and was probably also on the market right until the 7800, the 2600, sorry, which really had a long time. I think it was on the market for like 15 years. They stopped building it in the early 90s, 1990, 1991, 1992, in the cheapest junior versions. Frank Böppel is here and Matthias Danielsen. Hi everyone. I'm just talking a bit until more people gather, a little bit of the backstory. And I thought it would be nice to do a video mod on this machine here, because the early Atari consoles always only had an RF modulator, which is this thing. This produces a TV signal, an analog TV signal, which you can't use on any of the modern TVs. If you're lucky, you will have a composite input or SVideo input on one of the TVs, or you have like a converter box for analog video, but usually you never can use this RF stuff. Plus RF usually has a lot of noise associated with it, so it's pretty annoying. I also wanted to do a mod that is non-destructible, easily reversible, and doesn't remove any components on board. And this leaves you with two options. One is actually a cartridge, like this here, but this is the Concerto cartridge, which is a flash cartridge for the 7800. But there's also one, forgot the name, that's a cartridge that actually has RGB output on board, on the cartridge. But I didn't want that, because I wanted to be able to play actual games with video out, not only the flash cartridge games. Soul Sister AB is also here, from 2 rooms down here. Yeah, anyway, this left me with this mod here by the Brewing Company. Excellent mod called the UAV, the Universal Atari Video Mod, which you can use for all the 8-bit line computers, for the 2600, for the, I think even the 5200, and of course the 7800. But all the instructions that were available to me at the time were for the NTSC version, and in the last stream I figured out this is a PAL board, and a PAL board with a completely different layout from what I had expected. So we began reverse engineering, tracing the signals around, because we have two video chips on here. First the TIA, which is the television interface adapter from the Atari 2600. This is for the 2600 compatibility mode, and it has Luma and Chroma output, basically 3-bit resolution, I think, with the Luma, and the Chroma is some kind of analog signal, I think. And we have the Luma and Chroma output of the Maria chip, which is the enhanced 7800 graphics chip. Klaus Schmidt also has joined. Hello, Klaus. And both are combined in this OR gate here, I think, into one signal, and then somehow fed into the RF modulator. Okay, so I figured out most of the signals, but not all. We were missing maybe the sync signal or something else, and I didn't know where to look for it, so I gave up at the end of the last video with one signal missing. Plus, by now I also figured out that some of my signals were a bit wrong, in the wrong order. So even if I had soldered that stuff onto the mod, we would have had an issue due to me using the wrong schematic. In the meantime, I found the correct schematic, which is this. This is exactly the schematic that we need. If you only search for 7800 PAL schematic, you will find an original Atari schematic that is actually wrong, because it's for a different board revision. Most of the components are still there, but the layout is slightly different. However, this here is completely correct, and I quickly checked after the last stream that would work, but someone on the forums actually gave me a link to this thread here, the UAV RefD video upgrade installation on an Atari 7800 PAL, and I wouldn't have needed to reverse engineer anything of this, because here everything is actually very clearly labeled. The 4 resistors with the Luma 1, 2, 3 and composite sync signals. The, I think, missing Luma 0 maybe, I'm not quite sure which one we were missing. The Maria color output, the TIA color output, plus 5 volt DC and ground. The only thing that's not on here is the audio, which we'll have to trace down through the through this schematic here, which should be easy enough. There are 2 resistors that we would have to lift, but I think we can tap off of them as well with 2 additional resistors and a little electrolytic capacitor. Okay, so how do we install this? Well, the finished install is sort of shown here. We have the disadvantage of having the stupid SRAM board in here, which is another thing that Atari did for cost reasons. Instead of using the regular Sony, or what other brand do they have here? HMS, never heard of them. They are using these weird STC 8506. Oh no, I think it's 2168 actually. 8506 is the manufacture date. 2168 SRAMs. They're using these with some adapter here to replace the regular 6116 or whatever that is SRAM chips. Slightly annoying, but I leave that in place. Otherwise, you would just stick the board here onto the SRAM chip, which we can't. So I'll stick it somewhere else, but I probably leave it floating right now, maybe with some sticky tape. And I'm gonna hopefully turn on the soldering iron now. I think, yes, it's coming on. Great. And we will start attaching all the wires, at least the video. We can do the audio as well later, because audio will be on a separate plug anyway. The important thing here is that you have to note is there's one pad for the, come on, focus, +5, and for the ground. That is something that we take from this little capacitor here. On the left it's set. Let's take a look at the image again. On the left is the 5 volt DC here, and on the right is the ground. Furthermore, there is this big line of pins basically, and if we check the image after installation, they added a kind of pin header here, which we can also do, I think, if we want to have more easily pluggable things. Would make sense perhaps to do that. I have these precision pins here, and I think I can probably put them in, but I can also use a regular, but the spacing is quite different. No, the spacing is quite weird, but I think they should be connected to these outer parts perhaps. Let's check that and beep them out. We will have to attach at least the 2 wires here, then the 4 luma wires, that's 6, and the 7th for the sync. And the chroma, where's the chroma? The chroma comes in here, chroma in, I think. So that's a bunch of wires actually. But first let's check and see if we can install pin headers instead of these things here. No, it doesn't seem like that. I thought maybe they had something like that here. But I think their idea of doing this is quite different. It doesn't seem to be put on any of the pin headers here. Here's the, here in the bottom left is actually the tier color. And yeah, I'm not sure why they have so many pins here. I definitely can't do pin header in the middle, because that has a smaller spacing than my usual pin headers. And Fred has also joined. Hello Fred, long-time patron supporter. So we will have to collect a lot of things here. Yeah, I don't have small pin headers, so we will just solder it on like they are already. And I'll probably use, for the smaller things, I will use these wires that I have left over from a different project. I would need 5 actually, but I think their length is actually pretty nice for the resistors up here. I think that's pretty neat. Yeah, I fetched the instructions from, I need to call up a finder. I will fetch the instructions for the installation, a manual. Here it is, and they highlighted the different inputs. Yeah, they are actually on the smaller pin grid. So yeah, so basically what I showed you before, and you can see it also here. That's what we have to target. So I'll put in wires like so. Hope you can see that. That's in the hole named 1. That's the Luma 1 signal. And I put the board aside so I don't destroy it or anything. 3VI1J is also here. Hello. Hello world. Great. And this thing wants to go to sleep already. It would pay off to have more colors for the wires here, but I don't. So we'll just use nice green wires for all the luma signals. And then we have reds and blues, which also should be okay. Now this looks like it's stuck. Darkstar has also joined. Hello, Darkstar. And I think this should be relatively quick so that we can at least see video, and then we can have a look if we can also attach the audio in a useful fashion, and also listen to some sounds from this device. It's actually not that easy to solder to. I'm not sure why that is. Maybe because the pads are so small. Like so. And I need to be a little bit careful, I think. And I should have soldered the +5 wire on first. That's not my smartest move. I have a black wire here which I could use for the ground, maybe. Yeah, I think that might be a good idea. And I'm gonna use red for the +5, and I'm gonna keep it long because I can shorten it later. I think it's better to have it a bit longer. And I'm already cutting off too much, it seems. Okay. Let's tin this. Then attach it to the big +5 pad here, which will take a lot of heat. It's already on, and I'm gonna flow more solder onto it. And it went off. Straight went off. I don't think this mod takes a lot of current, because it's like 1, 2, 3, 4 little chips and some, I don't know, a MOSFET or voltage regulator, I have no idea. There's another transistor. Well, this is probably in a couple of dozen milliamps or something, I guess. Definitely doesn't need any external power supply. I'm going to use this super thick black cable, if I can get the insulation off. Otherwise we're going to use the blue cable for ground. Doesn't work. I do have a crimp tool. What do you call this thing? It's not for crimping, but it's for removing insulation. Yeah, okay, this looks better. Much better. Let's test for continuity if this is a good cable. Yeah, looks good. Let's take this. Wire stripper, yeah, that's a good name. Wire stripper. And let's attach this to the ground. And solder the black wire to this thing as well. Oh, this takes a lot of heat, because the wire is actually pretty thick. No, I think this works. Might be a little short. Let's see. But I'll attach the third luma here as well. So we have all the lumas attached by then. If I can get this through the hole here. Maybe I can't. The spacing is small and the holes are relatively tiny, I have to admit. Maybe the other wire? Yes, this works just fine. So yeah, the mod board is actually rather small. But the good thing is it should work for all the Atari devices, all the 8-bit ones at least. And it gives you SVideo output as well. We will start off with composite though, because I only have mini-DIN cables for SVideo, but I don't have a mini-DIN jacket, what do you call it, socket. So we won't be able to attach the cable. We also need a sync wire. I'm gonna use blue for that. And since we have the wire stripper now, we can use that. Let's take something like this. Should hopefully be enough. And twist this a little bit. And let's try to feed this through this hole labeled S like in sync. You could also call it the, I'm not gonna say it. I'm not happy because this is thin copper strands and they tend to stick out of the wire when I push it through, and they could be making contact with neighboring things, and I don't want that. And we have a short, and that would be very, very bad indeed. Yeah, I don't like it. I'm sure you can see that. But there's a thin little wire sticking out. See that? And if I pre-tin it, I'm fearing that it won't fit through the hole anymore. You really need a very small gauge wire for this. Yeah, I think that's it. So sync is on blue, and we will have to sort out the luma wires once we attach them. But we also need color, teal color, and I'm gonna use another red wire for that, so that we don't confuse anything. Ian Scott says, hi there, Route 42, is this the UAV mod? Hello, Ian. Ian is the inventor of the famous Pico Gus. And yes, it is the UAV mod from Brewing Academy. And it's the first time I'm using it, so I can't say if it's any good. I sure hope so, because it's a rather expensive mod. But it has the advantage that it leaves everything else in place and intact. You can easily reverse it if you don't want it anymore. And it should work with basically all the 8-bit Atari machines, including the 2600, the 7200, and so on. Atari 400, 800, you name it. And it also has SVideo, which a lot of the mods don't do. We're gonna cut off the excess copper wires here, because I really am afraid that I will short something out. Okay, we have almost everything in, except for the Maria color, I think. I do see them having 2 wires attached over here, but I'm not quite sure which. It seems the color in, yes, from Maria, that is fine. But they also have something else that goes on somewhere else. The yellow wire. Not quite sure. I'm gonna have a quick look at the installation. Solder your wires from the UAV video out section that will be connected to your AV out connections. Chroma and Luma. Okay. Okay. For SVideo, composite video out is composite. Okay. We basically only need to wire the Maria color in is, I think. Is it optional or is it not? That's a good question. Ian says, I installed one in my NTSC 7800 and it works great. Okay, Ian, if you know that already, if you have done that already, there is the input section, basically, or the output section. I do understand that Chroma and Luma is for SVideo, CV is composite video, G is ground. And then we have the color in. I do see that they attach it to the resistor over here, which I think is the Maria color signal, I think. Yeah, Maria color. So, is it correct? Basically everything is output except for that one pin which they made an input? That's sort of weird, but okay. So I'm gonna use another red wire, I think, because I'm not gonna install a screw post terminal or something like that. I don't think I have one in that size. But it's very weird to have an output terminal and have one input pin on that. I don't know why they did it. Okay, that works. I'm gonna be very interested in the results, how this will look actually. Once we have this in place, we can actually start soldering all the wires to the board. Maybe we want to attach the video out cable, at least for composite and ground, to some kind of RCA jack or something. So that's the Maria in. This is all the input cables, basically. And I'm gonna fetch a nice RCA jack. I'm gonna use a big bunch of jacks here. I'm gonna use one of these because then I can actually use it. This will be my composite video jack because I can actually drill a hole into the case. That will be one of 2 holes I will have to drill if I use composite only. And I can screw this right into place without any issue. And I have another one for the audio, which we'll do later. Scott says, looking at the photo of my install, yes, that is an input pin. If you ask me, it's a kind of strange design, but it works. Yeah, that's what I thought. I'm gonna use a relatively long lead here, so I don't have to resolder this. I can cut this at a later time. This blue one will be my ground lead, as I don't have any black wire. I think this should be enough because there's like, the case is not that huge. I'm gonna attach this to the ground pin here on the side. So I have the video ground very much right next to the video, which I hope is a good thing. So that's that. That's the ground. And we're gonna use another bit of red wire. I can find the end. Something like this. We use this as our composite video. And then we can also attach the RCA jack in a minute. And this will go to a composite video over here. Oh no. Okay. Here we go. Oh boy, this is, I need more hands. Ah, it's getting hot. Come on, come on. Yeah. That's looking okay. Yeah. Okay, this is the whole wiring harness. Now I need this. We can start connecting things up. So as I've told you, that capacitor over there is where we get the 5 volts from. So I'm gonna attach that first. This is color, this is 5 volts. And this is very annoying to get to with the stupid SRAM board. I think I do have no material. I think I ordered some SRAMs, but I'm not sure if they already arrived. Anyway, we'll just make it work with this one. So this is the plus 5 volts. Just making sure that it actually is. And it will go over here. I think I'm gonna tin the wire first. Will make attaching it much easier, hopefully. Hopefully, I said. Okay, I think this has attached pretty okay. Then we need the massive ground wire, which is right here. And it smells terrible. I forgot where I took this from. I think this is from the Commodore 8050. It had a mains filter that exploded while it was plugged into the wall outlet. Not even turned on, but that's what they do. And I saved the wires from it because you can always use bits of wires. Come on. Actually, this is way too long. I'm gonna short out against something else. I'm gonna make it much shorter. I might have to attach another wire in a minute or so. Yeah, anyway, the mains filter was something that quite a few devices had back in the 70s, sometimes even early 80s, due to regulations here in Germany that it's similar to the FCC basically in the US. But those filters contained, I don't know, some capacitors like similar to reefers that would blow up after a couple of decades. And since they are installed before the mains switch, they would actually blow up even when not turned on. This is why you should never leave old computers just plugged in. Use a switchable outlet or something, because you never know where something might blow up. And this is actually hard to attach. I think there's a little bit of corrosion on that capacitor. So, and I can really not reach down there very well. I think I've got it now. But it's definitely not beautiful. But it's attached. Both wires are attached. I hate this little board here on top. Definitely. Yeah, but that's my advice to you. Don't let anything just sit there plugged in all the time. Buy a switchable outlet. Just turn on your 40-year-old gear when you use it and when there's someone nearby. Maybe even with a fire extinguisher or something. So, let's start with the color in, because that's right over here. That is the upper resistor, the left side. Gonna tin the cable. Then we're gonna move this whole spider a bit out of the way. This reminds me a bit of installing PlayStation 1 mod chips. Never did that, but I've seen quite a few. And they're usually like spiders with half a dozen wires going everywhere. Use more flux, yeah. I will use more flux eventually. But this is of course flux core, rosin core, leaded solder, so it's actually pretty okay. If it gets harder, I will switch to the Emil Otto brand flux, which I use all the time. Okay, here we have the Tia color in for the 2600 mode, and we will try and play both 2600 games and 7800 games. I don't have any original 7800 cartridges. I only have the Concerto cartridge here, which is a flash cartridge, because this thing costs as much as like 2 7800 games here in Germany. I think the 7800 was not super uncommon, but relatively rare here. The TIA color is going on onto this resistor right here, and I already hate it because the 5 volt is in the way. Oh man. And more than that, the stupid SRAM board is in the way. It's such a horror. I really hate it. I'm gonna slip it right next to... Can I actually? I'm gonna try to slip it under the resistor to give it a little bit more strength when soldering. Maybe I should have run the wires all on the bottom side. It's actually not the worst idea, I think, to do the mod on the bottom side. Yeah, it's attached. Oh, it's so horrible. That was the TIA color in. Not shorting to anything, I think. I'm gonna take a lot of bets if this will work or not. The sync signal, I think, is next up. And then we will have to deal with all the Luma signals. Luma is actually the brightness information, and it seems to be digital on the TIA and the Maria, with 3 respective 4 different bits or levels. No, the levels will be 2 to the power of 3 and 4, I guess. And the sync goes to the resistor here, the third one. This is R66. 3VI1J says, I hope the output's good. That's a hell of a lot of wires to hook it up, if not. Yeah. It's supposedly a very good mod, but we'll see. And I'm trying not to melt the cartridge port. Boy. I'm gonna use a little bit of fresh solder here, because this is really. I'm gonna reflow also the neighboring resistors. Uh-oh. Now I made a solder bridge. Now it's gone. Because I think using a bit fresh solder will help in attaching things right here. I'm gonna look at the bottom side if I messed something up. No, this is still looking good. And I'm gonna try and attach the blue wire here. and I melted a little bit of the plastic on this tunable, what do you call it, inductor. And it's smoking. Yeah, it doesn't matter. I think I have one of these somewhere, because I removed one from a 2600. I have it somewhere, because this is one of the components that usually goes away with the mods that you usually do. Now I'm gonna look for Zero. Luma Zero is this one here. It's looking good. I think this is already tinned, but I'm gonna use more. Luma Zero goes over there on that resistor R29 below the RF modulator. I think Luma Zero is the extra level that Maria brings in compared to Tia. So this is Luma Zero, and this goes to, I'm gonna put a little bit of solder here to that resistor. Yes, this is actually looking good. I think if you do this mod a couple of times, it will get easier. This is definitely one of the more complicated mods that I've done. But maybe not so, because I don't have to remove any components. Like, I think the game gears were probably the most complicated. Luma 1. Luma 1 goes to R65, which is the top resistor of the 4 near the RF modulator. Oh boy, this is gonna be a big fat spider here. Oh my. Yeah, I'm gonna make it pretty later. I think this will just go up in flames. Okay, that's attached. Currently. Then we've got this wire here, which is Luma 2. Luma 2 will go at the bottom. Okay, well, this will be a spider's nest. If I don't like this, I will redo the wires, but I'm not quite sure it's actually possible to make it really, really nice. So Luma 2 goes here. And there's again that stupid inductor. I have to check how to get there. Yeah, got it attached. Nice and thick. Ian says, thankfully on the NTSC version of the 7800 all resistors to connect to are right next to each other, so I could use a tidy ribbon cable. Yeah, maybe I will redo this, but there are so many things running all around here, and I hate this board. I have to say it again, I hate this stupid board. Okay, this is the last of the Luma signals, which goes to the second from the bottom. And then we actually have everything connected that we need without audio. And we can attach the RCA, and maybe we'll be able to power this thing up, I would say. Okay, didn't attach. And I removed it again. Because I can't see a thing. Yeah, now it's attached. This is a horror, and I'm still thinking where to put it. Perhaps down here. This feels a bit like a natural place to put it. It would be on top of the 6502, which is supposedly running not as hot as the Maria chip. So they said not to put it on the Maria chip. Let's see. I'm gonna attach the RCA jack now. I do have a cable somewhere here, over there, for the video. I think I used this thing before, because there is some solder residue here. Okay, ground is attached. Come on. Come on. Ah, we got it. There's a lot of solder in here, so I will probably just try and melt it and melt the wire in place here. I think this is gonna work. And it's gone. Okay, here we go. It's not pretty, but it should work. Oh. And I'm gonna do two things. I'm going to hook up my video converter. I will use the white cable, I'm gonna say. Let's see. This is going into the yellow, and the white is also going in here, and we're going to use the bench power supply to make sure that nothing blows up too badly. And I'm gonna put something under here because I think otherwise we might have some short circuit. I'm gonna use no, that's also metal. I need something non-conductive, like cardboard, paper, or something like that. So, and I have to look up the pinout of the 7815. 7815 pinout. We have input, ground, output. Yeah, that's what I thought. Ground is the middle pin. Something like that. Oh, this is so close. Well, it should be okay. As long as we don't touch it or don't move it. I'm gonna turn this on. It is on SVideo. Now it's on video. And we're gonna switch to this perhaps. I think. I'll turn off this. But I think this doesn't quite work. I have to pull it out and plug it in again. 1 second. Are we still here? I think so. I have to quickly switch around once more. Ah, here we go. Here we go. I'm gonna turn off the website here. Okay, this is the video feed. Nothing there yet. I'm gonna turn on well, that's not exactly what I had in mind. The question is, there is a pot here, but I think that's more to do with yeah. Okay. We have 600 milliamps. I think that's fine. Yeah, it's not going over. I think the whole thing takes 600 milliamps. Gonna turn it off. I'm gonna risk a cheap cartridge. Here, I'm gonna risk a cheap cartridge. Seasick pills, yeah. Oh, you can see it. It's a German 2600 game Raumpatrouille, which is usually just a relabel of one of the more famous American games. But I think it will probably show. Ah, look at this. Well, there's something there, and it's very noisy, and seems that the color goes in and out. The Luma signal seems very, very sharp, I would say. But the TIA color in signal doesn't seem to be super happy. What happens if I gently turn the knob? Nothing. Okay. But it's definitely doing something. Since this is working, let's try the Concerto cartridge. Concerto. I've never used it before, and I hope it doesn't break. There should be asteroids built into the 7800. This gives us nothing at all. Oh, here we have the noisy color signal again. And it takes a little bit more current. Weird. Let's go back to the Raumpatrouille. That's not about a rat that cooks, is it? No, I think it's a space game, obviously. Space Patrol is the English name. Something is really off with the color. Interesting. I think we need to read the manual a bit. I mean, it does work. We have, at least for the 2600, we have composite output. The graphics look nice and sharp. The color is non-existent, which is quite interesting. I wonder why. Okay, let's check the... Maybe I should have read that before. Let's check the text here. The UAV is a great thing. The single board can be used in virtually every 8-bit Atari console and computer, but since there are differences per machine and per UAV revision, you have to know exactly which wires, jumpers and pins are really relevant for your configuration. The long nature and discussion in the main thread make it hard to find the right information. I'm gonna turn this off for now and turn back to our capture from the desktop. You do not have to remove any existing parts from the board or for the UAV itself. You may have to remove parts to grab the audio correctly. Yeah, that's where you lift two resistors, but you can even avoid that, I think. I have to use the RevD board, which we have. It says RD. Without connectors, because there is no driver 4050 chip in the Atari 7800, but a 7432 chip, which combines the video signals. Yeah, that's the chip right here. From Tia and Maria into one. Basically, you grab most of the required signals from the resistors connected to the 7432. Yeah, that's what we figured out in the last video. You will typically not be able to read the RXX, CXX labels on the populated board. Yes, exactly. Therefore, it is important to know where to connect what. When connecting to resistors, use a meter to check the value of the resistors to make sure you're at the right place. I think I can safely say that we are at the correct ones, because there's really not much we can do wrong here. I would say that at least our Luma 1, 2 and 3 signals are right, because the black and white picture looks great. I also think that the composite sync is correct, because we have sync on the 2600. It might be that we have an issue. We do have an issue. I used the wrong resistor for the Maria color. Already see that now. Okay. Easy to fix. Easy to fix. But I would have assumed that that shouldn't have a big impact, actually. Except if I killed the Maria chip now. Which is always a possibility. Which would be very, very, very unfortunate. Okay. That's the Maria color. This one is correct for the Luma 0. That's fine. And that is supposed to be the Tia color in. Who knows? Maybe the whole color problem was due to the Maria color. Let's see. Let's see. I'm gonna switch back to our capturing here. I will turn off the website for a second. Fingers crossed. I'm gonna leave no cartridge in, because there is asteroids built in here, which might fire up. And it does. But the color signal is extremely noisy. Interesting. So we do have Maria video now, stable Maria video, which is good. We can test out, there's the demo attract mode for asteroids. We can test the Concerto cartridge now to see maybe something different on the 7800. But it shows only black. That's a bit disappointing. I'm not sure what to make of the color. Let's put in a Raumpatrouille, Space Patrol. Ah, okay, I wanted to say the graphics look different, but not really. So the color is all messed up, I would say. Is there anything happening when I touch something? Is there like a... I don't know. Difficult to say. Black and white looks astonishing. The question is also, is this an issue with my capture device, like the converter? Is it? But I think it actually has usually no problems with composite input. And the noisy color signal looks a bit to me like there is no color, but it tries to amplify the color signal, and then we get like tons of noise, which is something like 3VI1J says. In 7800 it starts off immediately with color, but it's super noisy. So I'm not sure that is actually a proper color signal. I think this here has to do with color, or should, but doesn't. No, it has no influence whatsoever. Interesting. Definitely looks like chroma issue, says Ian. Yeah. That's about right. I mean, we can hook up the oscilloscope, I think. Would probably make sense. 3VI1J says, yeah, would definitely question whether that's connected. The thing is, we don't have chroma on either the TIA nor the Maria graphics, which is a bit suspicious, because I have attached this here to there. That's also looking fine. And is anything getting super hot here? No. No. We bypassed the regulator. The Maria chip is slightly warm, but I think that's normal. Totally normal. That's quite interesting now. The TIA color is really connected over here, I think. So, what are our options? What is going where? We have the Maria chip here and the TIA chip here. The Maria has the color signal going off on pin 43 and running down. Color signal runs down here. Down here, down here, down here. Through R25. Through an inductor. Through a capacitor. And somehow here into this transistor. Okay. And we are picking it up from R25. Dexos here. Where are my pictures of any use? Probably but I actually didn't need them because I'm gonna put this on the screen again. There was actually already a thread on Atari Age with all the required points of interest on the board. So I actually didn't need your particular pictures. They didn't hurt for sure, and were also quite insightful. But in the end I could look everything up here and determine that some parts last time we identified correctly, some parts we jumbled up, but now we have everything in place. So the issue is that we do get a picture, a stable picture, but we seem to have no chroma signal whatsoever, which is weird. So what I'm gonna do now, I think, is getting an oscilloscope and having a probe at the color in here, for example. Stefan says, I'm not familiar with your circuit, but if you have a video circuit with transistor amplifiers, the supply voltage is crucial. Okay, I mean, we can test the supply voltage, but I think it should be 5 volts. Because that's what my power supply here is saying it is delivering. So let's have a quick check. Can you see? Yes, you can. Partially. You can't. You can't. I have to disable the... I don't want to disable this. I just want to show it like this. Now you can see it. So I'm gonna carefully probe in between these two, and it shows 4.9 volts. I think that should be sufficient for this mod board, I think. But the question is, again, what's happening with the chroma signal here on the board. So I'm gonna fetch the scope, if you excuse me. Ay. Here is the scope. Question is, where do I put it? I don't have any space. But I have the Space Patrol over here. Put the Space Patrol here. Put that here. And then we'll have to check if we can remove one of the probes for now. So I can use auto something. I'm gonna use this, and what I'm gonna use for ground, we will see. We will see. I think I'm gonna use this for ground. I need a power cable, which I had earlier today. There is one. And I'm gonna think about if we can... But the multimeter cannot measure the noise. Okay, yeah, we can of course measure noise. Certainly. We can use the scope to measure noise on the power rail if we want to. But right now I have to find something that I can pull out to get this scope running. And we might want to have a video capture of the scope, I think, right? Right, which we can do. It will be only 2 frames per second or something, because this is a cheap scope, but better than nothing. Stefan also asks, any caps on your video mod board? I guess so. there are probably quite a few caps. Okay, the scope is getting warmed up. I'm gonna switch out the website for the scope view. This will take a second. Okay, I'm already seeing a signal, which is nice. Interesting. Didn't expect that. Where am I triggering? Well, never mind. I'm gonna try to get you a view of the scope onto the screen. Can we please connect to the scope? Yes, it does. Okay. How can I change the trigger to channel 1? Okay. There is definitely something happening here, and I'm gonna try and show you. Where is the DS remote? Here. And here you go. I'm going to make it bigger. So, on channel 1, the yellow channel, we see nothing right now. Because I'm not properly grounded, I think. Or I lost contact here. It's a bit iffy here. But you can see there is a signal with a certain frequency, I think. I do see something repeating. But it's very hard to get a proper connection here. I think this is a better connection. Yeah, I have the ground floating right now, which is probably not optimal. Trying to connect it here. That should give us a bit better connection. Okay, I think now we have a pretty stable view of the oscilloscope. You can't see that, but I see a lot of spikes in between that jitter through time, basically. And there are these regular intervals, which I guess are individual lines or frames. I can't really say the frequency right now. I think it's 15 point something kilohertz. That's what I sometimes get shown here. I think you can't see that here. I'm wondering how I can change. I have to change it here in the tool, the frequency measurement, but I'm not quite sure. Where I can find this. This is only triggering measurement counter here, channel 1. Okay, it should say, okay, it currently says something like 100 kilohertz, which I don't quite believe. I do see most of the time 15 kilohertz in my instrument view here, which I think only counts these things. I think these things here are basically individual lines. I think those are probably color signals or something. 15.6, yeah. Stefan says, any caps on the video motherboard? Is this H sync with BW signal? Why? 15.65625. Stefan, I have no idea. This should be the Maria chip's color signal. So only the chroma signal without anything else. Which for some reason seems to be very noisy or non-existent. So I don't think this is any sync signal in there. That should only be the chroma signal for every line, I guess. That would make the 15.6 kilohertz, I think. And the intermediate spikes that we see are probably the sprites moving through there, I guess, plus the asteroids logo or something that gets displayed, I would guess. And everything else is black because this is a, well, basically a space game. If I turn this off and put in Raumpatrouille, we shouldn't see anything on here because Maria is inactive. There was something for a very short while, and then there is nothing. We see very small signals here, but I think they probably get ignored. That's maybe crosstalk from the other wires or something, I would guess, or I don't know. But on the TIA input there's also no color, as you can see. I'm gonna grab the, oh, I shouldn't do that like so. The TIA color is over there. I'm gonna turn this off, just as not to short out anything. And I'm gonna try and pick it up just with the pin here. So I'm gonna turn it on again. So here we go. And there's definitely a lot of signal, but it looks to be inverted, I would say. This looks like the inverted version of the Maria signal, actually. Also 15-ish kilohertz. Maybe there's a kind of color bar on the left or right. Yeah, that could be. Not visible to me anyway. Okay, Raumpatrouille Orion, pure black and white. Yeah, pure black and white, exactly. For some reason, but sometimes color comes in and goes again. So the question is, where is our chroma signal? Why doesn't it get through, is the question. So let us have another look at the instructions, perhaps. I'm gonna capture the instructions window again, if I can find it. Here we go. So you can also see it. Leave the rest on. So this is the board. We have the Maria color coming in here. We have the TIA color coming in here. The luminance and the composite sync are fine, I would say, because we have perfect black and white picture. And we have correct sync, because the picture is stable. So the only issue we have is with this here and this here. These are the input pad locations. They are different than RefC. Yeah, okay, we know that. We have all that. Yeah, 8 solder points, and they are all simply on one end of a resistor. It's actually easy to do and remove if required. Okay, on the CRT, but the LCD complained with no sync. TigerDuck adapted the soldering and reports it's all fine now. I've updated my pictures accordingly. Now I feel like I have the black belt in NS Paint. Okay, this is how it looks on other people's machines, but what output signal are you using? I'm using the composite. I mean, I can probe the chroma output, maybe, with the oscilloscope perhaps, to see if there's anything useful coming out there. I can't hook it up to my converter because I don't have the correct cable, sadly. So let's switch over to the oscilloscope. Here's the oscilloscope. And we're going to probe it like so. And there is indeed not a single chroma signal, I would say. There's a bit of noise at about 1 volt, I would say. Yeah, 600, 700 millivolts, thereabouts. It should be a bit more. 1.36 it is actually. So that's pretty much garbage. I'm gonna switch to asteroids once more. Same here. No chroma output. Composite is luma plus modulated chroma in one signal. Exactly. So we don't have any chroma, even though we do have correct chroma input by the looks of it. If I probe here again, this is the Maria chroma input, and I would say this is fine for what's happening on the screen. I'm not quite sure why the concerto cartridge isn't working, but this seems to be more or less correct. And we also had TIA color on the TIA pin, which is also fine, I would say. Switching back to the Raumpatrouille and to the other pin. Here we go. Yeah, it looks to be inverted, but I don't know. Maybe that's just how it is. So there is definitely no chroma happening on the board. Question is, why? I think correct chroma input before modulation? I think so, because that's what we just probed, didn't we? Or do you mean something different? My guess would be that we lose the chroma somewhere here on the board. Question is, I have no clue how this board works, so I can't say which components do what. I don't even have any idea which is which. So I might have to ask the Brewing Academy people, perhaps, because I think everything here is connected correctly. Everything looks to be in order. But no modulated chroma output after modulation. Yeah, basically, whatever this board does, I see no chroma output signal. What we can try is, I can twist the pot here and see if it changes anything on the chroma output. That could be an interesting thing. So we have 1.3 volts on the chroma for some reason, and twisting the pot does absolutely nothing. There's nothing happening here. I don't see any difference. So I would say maybe this board is broke? Perhaps? Not quite sure. What do you people say? What might this issue be? Because everything is connected correctly by now. And the question is, what happened here? That would be very interesting indeed to know. One thing I do want to know is if I turn this on and if I find my multimeter, what is actually on. Isn't there some sort of port on the board? Did you try fiddling with that port? Yeah, I did exactly that. So my current hypothesis is that I might have broken the board, or it was broken, when I attached the wire to the other resistor down here. Let's show that again. I'm gonna turn this off and turn over to the desk once more. So my issue was that in the photo they showed, because there was a label across that, they showed this resistor here to be the Maria input, and I've now got the Maria input on there, and but I attached it to this one because I kept in my mind, okay, it's the lowest one here below this group of resistors. There was only one visible because they put the label above this one here, so I attached it to this one. I just measured that there's 5 volts on this resistor, and the video signal seems to be much lower. Although technically not, I think I saw 5 volts on there too. So I think 5 volts shouldn't be too bad, but it could happen that that I maybe destroyed a chip on here that does the modulation or something. Stefan says, I acquired a 7800 as well 2 weeks ago. Can you show the webpage of the video mod board or the name? I want to look at the circuit diagram. I'm not sure they supply a circuit diagram. You have to look for Brewing Academy UAV. Let's call it up on the web browser. No. This here is the web browser we want to see. And let's go to Brewing Academy. The Brewing Academy. Here they are, and yeah, okay. Closure days. And they have the UAV here. And I think they don't tell us the circuit diagram because it's not open source, sadly. There is the instruction manual, etc., that you can get, but it doesn't say anything about that as well, I think. Yeah, but you can look for it. And that's exactly the thing that I have. I only have the downloadable manual as well. I just basically took the cheapest version that I could get, so to speak. Yeah, but you can have a look. So that's the mod that we're using, and for some reason the chroma signal doesn't get through, not at all. So my plan would be now to drop those people a note and ask, can I probe something? What could be broken? But I think we're a bit stuck today again. We managed to do a little bit of progress here. It's definitely more than we had the last time. We do have video for black and white, more or less, but we don't have any chroma signal coming through. I mean, I'm not even sure. I mean, I can take close-up pictures and post them on my Mastodon account or something, but you can perhaps also make it out like so. There's like 2 chips on the top, which are a 7485 variant and a, good grief, is this hard to read? Another 74 variant. Maybe I can show this by taking the camera down. Ooh, here we go, here we go, here we go. Is this readable? I think it is. So one is a 7486, I think, and the other is a 7485. Stefan says, thanks, I will check. Is there a chip on it with a number on it? Yeah, of course. Lots of chips. And on the bottom side, there's even more. Let's see if we can make it out. So there's one resistor up here. There's one large-ish chip that I can't make out right now, but you can probably by doing a screenshot. And there's another smaller 8-pin chip below that. And this down here is, I don't know, maybe a voltage regulator, something? I don't know. You tell me. Okay, that's all I can say for now. So my guess is something on this board is now broken on the mod board. Question is what and how easy is it to repair? If it's one of these chips, I can probably maybe replace it myself. But there's so many things I'm really not keen on doing that because it's double-sided and everything. That would be very annoying if that were to be broken. And the question is also why. Because I think the color signal is also 5 volts. Hooking up to the 5 volts on that side of the resistor shouldn't make a difference, I guess. Because that would be like just the signal being on all the time. I should think that this whole thing is 5 volt tolerant. Even though maybe it has a voltage regulator and some 3.3 volt chips down there. I don't know. No idea what that chip is. Yeah. Any comments? Otherwise, I think we can close this stream. Again, not quite there yet. It seems the elusive 7800 is a console that not so many people like to play with, exactly due to the problems that you have with modding them, or maybe I'm just too, well, I don't know. I don't want to say stupid, but inexperienced with this thing. As I said, if you do this like a dozen times, it's probably getting easier. Ian says, hope you figured it out. Yeah, I hope so too, because I spent a lot of money on this stupid little board. And would love to see this thing actually working on a composite monitor. Like on the Philips CM8833 or something. That would be nice. But I don't think we will get it running today. So yeah, thank you everyone for watching. I see that there were quite a few people in the stream. Also quite a few comments. I won't give up on this. We will make this thing run. The 7800 is too much of an interesting machine, I think. I'm also wondering why we didn't get any output from the Concerto cartridge. Because I think that should definitely work. But who knows? Cool shirt, says Ian Scott. Yeah, that's the Monkey Island shirt. I I'm not sure if I haven't used this. I only have used the Harmony cartridge, which should work. Let's have a very quick last look what the Harmony says. That should work. Yeah, that works without color, obviously, and the lines are because it heavily uses interlacing to get higher resolution text. So that does work. My assumption would be that the concerto also should work out of the box, but maybe I didn't put the what do you call it, the firmware correctly on there. But we don't get any video output now. Weird. I haven't tested the concerto yet because I didn't have any video output, so I can't say. Interesting. With the concerto inserted, we don't get any video output. Draws slightly more amps, but that's it. Yeah, I have to figure that out. I remember on first boot my concerto had to flash itself. Well, that is a possibility. That would explain quite a bit. Maybe we can test that as last thing, because I think I put everything into a subfolder. Maybe that's not wanted. And the question is, do I need firmware? And where do I get the firmware? Let's have a quick look. And you can look as well. Gonna put this down here. Atari Concerto. Is this the one? Okay, let's download this and put this somewhere on here, I guess. Where did it put this? Here. Let's copy this to the cartridge. Okay, let's see if that works. If my computer lets me eject the SD card, actually, which it did. Perfect. Let's put in the SD card again and let's try it once more. No, okay, you have to use a... Okay, that doesn't work like that. You have to use a little flash program. Okay. There's a special program here. And you have to flash it. Question is, do I have a cable? They use micro USB. I have a micro USB cable here. I think somewhere. Maybe here? Yeah, this looks to be correct. And we need a finder. No? Okay, let's try this. So hopefully this has data connections. You never know. Ah, goodness. Apple says it doesn't know the developer. Open. Sorry, gotta go. I hope you figured it out. See you on the next Lötstream. Yeah, goodbye, Darkstar. Thanks for checking in. Okay, here we go. I'm gonna let you see this as well. Here we go. This is the tool. Select the location of the EEPROM load image, usually EE loader bin, and download it to the Harmony card. Where do I find it? Where do I find it? I don't want the NTSC bin file. They only give me the NTSC bill file. I don't get this. Harmony card not found. Okay, that doesn't help either. I think this this is only a charging cable, one of those cheap ones. Okay, I will do this another time. It's getting late. Okay, so probably I need to flash this still. I forgot that how or if I did this ever for the Harmony card, because it was just running for the past 5 years. But that's where we are. Concerto card doesn't really work. Color is missing. Video works. Well, it's a bit disappointing. My next step will be to contact Brewing Academy and ask them for help, because I think that's probably the best idea. Anyway, thanks everyone. Let's have a look. Does this thing still live? Yeah. Still no color, but hey, that's no proper color, just color noise. That's it for today. Thank you very much, and see you in the next regular video or the next Lötstream. Bye!